This is a rigid body equilibrium reassessment. A house painter is standing on a uniform horizontal platform that is held in equilibrium by two cables attached to supports on the roof. The painter has a mass of 75 kilograms and the mass of the platform is 20 kilograms. The distance from the left end of the platform to where the painter is standing is d is equal to 2 meters, and the total length of the platform is 5 meters. How large is the force exerted by the left-hand cable on the platform? How large is the force exerted by the right-hand cable? So, here's our picture. We have our two cables. We have our distance. Here's the painter. We have our distance from the painter and the distance of the whole board. So, the summation of the forces, the summation of the torque around the point is equal to 0. And summation of the forces are equal to 0, and our weight is equal to mg, so that means we're going to find the weight of the board plus the person, which we have here, the weight of the person plus the weight of the board times gravity, and that gives us 931 newtons, which are equal to our two forces here. And when we have this, we can solve for f of r or f of L. So, summation of the forces around a point, or the summation of the torque around a point is equal to 0. And so, right here, we are going to use our right as our point. So, that's the point. So, we have f of r, or force of right, which is 0, because that's the distance, plus f of L, which is 5, because that's what it is equal to mass of the painter times gravity times the distance, which would be 3 meters from this point, and then plus the board, the mass of the board times gravity. That's 2 times 2.5 meters, which is where the painter is. I mean, not the painter, the middle of the board. So once we solve for all of that, we're given the force on the left side is 539 newtons. So we just come over here, plug in what we know. We can figure out the force on the right side, which is 392 newtons.